Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to do a chatbot implementation. This is part of NLP. This is the 18th video on NLP. I am doing some of the algorithms. I am using some of the algorithms from NLP like cosine similarity and TF-IDF vector algorithms. These algorithms also I am using. Let's start. One second. Let me close this. Fine. We will start now. The implementation part, we will start. As I discussed, this is the 18th video on NLP. We have covered most of the algorithms and their practical implementations also we discussed in the previous videos. You can see those videos. See, as you are aware, Chatbot is a computer program that simulates human conversation through voice commands or text chats or both. Chatbot, it's a short for chatterbot, is an artificial intelligence feature that can be embedded and used to through any major messaging applications. Fine. See, these are all the softwares I am using in this implementation. NLTK, you are familiar, Natural Language Toolkit, sklearn and Python, and I am using Anaconda. I have installed all these softwares on top of Anaconda, and I'm using the Spider IDE, that is along with Anaconda. You will get it when you type Spider, you will get that IDE. NLTK, Natural Language Toolkit, is the leading platform for NLP. Using, you can use a pip install NLTK to get this, and NLTK.download will give you the all the data set and everything related to NLTK. You will get this window when you download NLTK. And the machine learning model and algorithms, as I discussed, I am using TF-IDF and cosine similarity. These two algorithms I am using here for the implementation. TF-IDF algorithm or word frequency algorithm. TF-IDF, term frequency, inverse document frequency. This is a technique to quantify a Word document. Here we will find out the weight of each word using mathematical formulas. That's what we do here. Each word is associated with a weight to each word. That's what. So this is the math of TF-IDF. Term frequency, how we will calculate the weight, that is term frequency into inverse document frequency. What is term frequency means? Term frequency measures the frequency of a word in a document. This is the formula for term frequency. You can note it. And document frequency, this measures the DF, document frequency, is the number of documents in which the word is present. That is the document frequency. See, I have separate video in the NLP. I told you, this is the 18th video. So you can, if you want more clarity on this algorithm, you can watch the separate video for TF-IDF. See, this is inverse document frequency. Term frequency is how common a word is. Inverse document frequency is how unique or rare a word is. See, this is the formula for inverse document frequency. It is the logarithm to the base e into total number of documents divided by number of documents with t in it. T means term or word. See, cosine similarity is the, as you know, it is the cosine is the angle between two vectors. See, vectors, there are two types of products. One is the dot product and cross product. In cosine similarity, we use dot product. This is the equation. A dot B is equal to AB cos theta. Here this A is the magnitude of vector A, this B is the magnitude of vector B, theta is the angle between vectors. Vector A, this is vector A, this is vector B, this is the dot product. So from here you can write cos theta is equal to A dot B divided by AB. This is the vector, this is the cosine angle, cosine similarity. This is the math, this is the equation we use for cosine similarity. If you want more clarity on this, you can get, I have a separate video for cosine similarity. You can watch that video. See, this is the point. The closer the cosine value to 1, the smaller the angle and the greater the match between vectors. This is the concept, because cos 0 is 1, cos 90 is 0. in that way you can understand that. See where it used, cosine similarity is generally used as a metric for measuring the distance between the magnitude of the vectors does not matter. See here, when where do you use cosine similarity? When the magnitude of the vectors is not important. This happens, for example, when working with text data, the magnitude is not important. So cosine similarity algorithm you use when the magnitude is not important. You understood that. So this is the cosine similarity. This is the mathematical equation I already discussed. Cos theta is equal to a dot b by modulus of vector a by modulus of vector b. Now let's get into the implementation part. For that I will get into the spider IDE. Before that, see, this is the document I am using for the chatbot. You can see this document. This is a document for artificial intelligence. This I copied from the Wikipedia. If you search artificial intelligence, you will get from the Wikipedia. I copied this information. You can search artificial intelligence and you will get this information. Okay, so from Wikipedia I copied this document. This is the input to our chat program, so I can ask questions related to artificial intelligence to my chatbot. You got my point. Now I will get into the program. See, I have the program with me. I'm just copying it and trying to run it in the spider ID. See, as I discussed, I am using spider ID. This one I didn't explain you. This is the spider IDE. This is the anaconda. This is anaconda. Here, when you type spider, you can see it here. When I type spider, I will get this IDE. It's a very useful IDE. You can if you install anaconda, you can use this. Otherwise, it's fine. See here, I'm going to run the program. As I discussed, I am using cosine similarity and TF-IDF vector as well. These two algorithms I am using in this program. Now I am getting into the program. This is the program. See, as I discussed, I am using NLTK, Natural Language Toolkit. See, that also we can do a pip install NLTK, then you will get that. See, I have already installed those aspects, so I am just using it. See, in most of our programs we are using NLTK, so I am just copying this code. Here I am importing the necessary libraries: NLTK, NumPy, random, string, warnings, everything. If you run it, you won't get any error. See, this, it's running fine. Now I will this is the place where what I am doing is I am getting that Word document. See, I told I have this Word document stored in my system that is related to artificial intelligence, and the questions we are going to ask to this chatbot is related to artificial intelligence, and those informations must be there in the document. So what is this document? This is artificial intelligence.txt. I can show you that document. I saved it in this location. See, this is the document. Artificial intelligence, it's in the location d:/tatumasi NLP chatbot. See, here only I am saving it. I have given that path. See, that's what I have given here. You can see here, open d:/tatumasi NLP chatbot artificial intelligence.txt, errors, we ignoring the errors. See, after that we are reading the document and we are converting into lowercase. Then I have you can download. Here we are using NLTK from there, Puncti and WordNet we are using. If you don't have those things, you can download, because I have already downloaded. That's what these codes I can show you. See, these are all the download you needed from NLTK to run this program, Puncti and WordNet. I have already done it. So if when you are running for the first time, you can download that as well. So I am commenting that. Done. And after that, see, we are getting the sentence underscore tokens and word underscore, see, converts the document list into sentences, and this convert into words. This is word tokenization using NLTK. See, you have the NLTK. See, I am using the libraries, the methods from the NLTK. See the document we are passing it here. So you have word tokenizations, and I have separate videos, the implementations for word tokenization using NLTK, using TensorFlow. You can watch those videos. So it's simple. Just we are tokenizing these information. That's what we did it there. Now if you want more clarity, see, I can show you. If you print this, you will get that informations here. See, to understand more what is tokenization, I will show you. See, I am running it, this piece of code, send token. I am saving it sentence underscore tokens here, print send token and print word token. I am running it now. It will see, this is the sentence token, right? This is a sentence, and this is the word token, the first two words. See, I have given column 2, right? So I will get it like this. You understood? It's easy, simple. Now what I am going to do is, next I am going to do we will get into the remaining part of the code. Here we are doing the pre-processing. You are familiar with these aspects: lemmatization, stemming. If you are familiar with NLP, you may be familiar with lemmatization and stemming. I have separate videos for lemmatization, stemming, and their implementation using NLTK. You can watch those videos. In this part, we are doing the pre-processing. If you watch the life cycle of an NLP project, I have a separate video for the life cycle of an NLP project. There also it's, this is the method, this is the steps we follow when doing an NLP project. Next we have to do the pre-processing. See, that's what. See, I am nltk.stem.word lemmatizer. That's the method we use for lemmatization, and you will get the lem tokens here. This method is returning that. And you have the uh, WordNet. Here we see WordNet is a semantically oriented dictionary of English included in NLTK. So we are normalizing the text using lem normalize method. There also we are lem tokens. There we are using the NLTK word tokenize, and we are using the text dot lower. These methods will do the normalization. So this is in this code will do the pre-processing for the text file that is served in this document. This is the document we have. So you can see in computer science, artificial intelligence, sometimes called machine intelligence, is this is the document we have given. It contains a lot of information related to artificial intelligence. This is what we have it here. See, even it's having information related to natural language processing. See, this is, you can see natural language processing. It's also there. So you can see this document fine. Now I am getting into the program again. So we have done the lemmatization and stemming, and that's pre-processing we have done. Now we are getting into the greetings. So greeting words, how do we do that? That's we will do, this piece of code will do for that. So you must be having some idea about natural language. It's easy actually. You can get watch those videos, and you can easily get to do this NLP. NLP is a it's, if you take some interest, it is very it's very easy. So these are all the greeting inputs. You can get hello, hi, greetings. It's it's there. After that, the greeting responses, hi, they, it's, I am included notes as well. Hi there, hello, I am glad you are talking to me, like that. So a definition, this method greeting sentence for word and sentence dot split. If word dot lower in greeting inputs, return random choice greeting responses. From this it will choose the greeting responses. You are getting that? It's a simple. That's what, when we approach the chatbot, it will tell like hi. When we tell hi, it will also tell hello, like that it will respond. So for that only we are using this. It's a simple Python piece of code. You can easily understand that. Now I am going to getting into the vectorizer and the cosine similarity. There only this is the heart of the program. There only it's doing the how it is fetching, how it is mainly it is using the vectorizer TF-IDF vector. It will use you need to understand TF-IDF means it will find out the weight of the word, the how much the word is important. That is the TF-IDF vector algorithm. Cosine similarity means the similarity between two sentences, two documents. How the similarity is it? What exactly it is telling. That is the cosine similarity algorithm. We are getting into that part. So these two algorithms only I am going to implement here. See, I am getting it. I am going to save that code. That is the vectorizer and the um, see this part. It's pretty easy. I will tell you how it's working in the see from this TF-IDF vector and the cosine similarity. It's we are getting it from sklearn. So I am importing from these two algorithms from sklearn dot feature extraction TF-IDF vectorizer and the cosine similarity. After that, I am writing this function response. There I am passing this user underscore response. Then this on chatbot underscore response. Here we have the sentence tokens. In that, see sentence tokens, we have it already. We are appending the user response here. After that, you have the TF-IDF vectorizer. Then it's taking two attributes tokenizer. That is the lum normalize. You can see here it is this only it's taking. That's why we have written the lum normalize method. And it's there lem normalize and lem tokens, it's already there. And you have the sentence tokens. It's we are getting it from the document. Sentence tokens and word tokens beginning we have got it. You can see it here, sentence tokens and the word tokens. This we have got it from the document using the NLTK. And you have the lem tokens method and lem normalize. So by using this one sentence tokens, to that we are appending and the TF-IDF vector. So there we have given the lem normalize and the stop words also we are writing here from the English. Then TF-IDF, after that we are calling the fit underscore transform method from the TF-IDF vector and passing the sentence tokens. Then to this, the cosine similarity, there we will give this object TF-IDF object, we will pass it here TF-IDF -1 comma TF-IDF. Then we will get this values dot argument sort, that is 0 to -2. Then we will do the flatten operation here. We will do the flatten and we will sort it. This is what we do it in this is the most important part. This is the heart of the chatbot program. To understand, it's very pretty easy if you have idea on these two aspects. One is the TF-IDF vector algorithm and the cosine similarity. You need to understand TF-IDF vector give the weight of each word in the document, and the cosine similarity give the cosine distance between two documents or any two documents. So two vectors, mainly we call it as vectors. So the distance between two vectors. So what does exactly it means? The distance where we use this algorithm when the magnitude of the vector is not important. That means mainly cosine similarity, the cosine distance we use related to documents. So you understood that. Then we are writing if requirement underscore tfidf is equal to 0, that then the chatbot will respond, I am sorry, I don't understand you, because we don't have, if I am giving an information that is not, I am asking a question that is not there in that document, it will give, I am sorry, I don't understand you, like that it will respond. That is the chatbot response. See, chatbot response, chatbot underscore response plus sentence tokens. These tokens, how we are getting it after doing the TF-ID of vectorizer and the cosine similarity algorithm. It will do the weight of the vectors, then it will compare our question. That is the cosine similarity. The question will be compared with the document. That is the cosine similarity algorithm using, and the TF-ID of vector will find out the weight of each word. Like that, it will fetch the data. You understood that? Fine. After that, again we are this method, this is the main implementation part of the, this method is really important. Now we are getting into the last part of the program, that is it is the this much only, how we will print the result. That's what I'm giving, you know so this here, it is return, it's sending here, 1 second, I think it's giving an indentation problem. Yeah, now it will be okay, I believe. Yeah, it's gone, right? So Python, the indentation is very important, right? See, we have given flag is equal to, see, till here we have explained, return this code till up to here I have explained the code to you. This is the code, now I paste it in the spider id. I am going to explain that code. It's pretty easy. Flag is equal to true. That's, we define flag as true. Then print chatbot. My name is, see, my name is chatbot. I will answer your queries about a artificial intelligence. If you want to exit, type want to exit. It's you. We have to type by, like that. If we type by, it will exit. Then while flag is equal to true, user underscore response is equal to input. Input means what we are typing, the questions. User underscore response is equal to user underscore response dot lower. We will converting into lowercase. Then if user underscore response is equal to by, then it will thanks. It will it will give you a message like thanks or thank you. Then flag is equal to false. It will be flag. We will make it as false. Then print chatbot, it will give you a message, you are welcome. If it's not like that, if the message is not by, if greetings user underscore response is not equal to none, print chatbot greetings. That's, we have already written in the, that code is written in the top, that greetings. Then else print chatbot and print response user underscore response. So here it will type the response that we are getting from the previous method. All right, user response, and else flag is equal to false. Again, chatbot will give the message by take care. So this is what exactly the program. Just I am going to run this program. Let's see how it will work. I will show you here. See, I am running the program now. See, it's giving a message. You can see the here you can see chatbot is giving a message. My name is chatbot. I will answer your queries about a. If you want to exit, type by. Then I will giving a message like hi, then it's giving hey. It's also chatbot is responding. I have written some questions in the chatbot questions. It's there, these are all the questions I tested in this application. See, these questions should be related to the document it's given in the program. So the first question, it is, what is artificial intelligence in computer science? So our first question, what is artificial intelligence, artificial intelligence in computer science? That is the first question. It's responding. Chatbot in computer science, artificial intelligence, sometimes called machine language, is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals. We will try the next question. See, what is the full form of AI? See, I have given that information in the document. See, all the questions, those informations must be there in the document. This document, I copied it from the Wikipedia. This information, I put it actually, this is not there in the Wikipedia. I included here. The full form of AI is artificial intelligence. I have included in the document. I am asking that question to the chatbot. What is the full form? Sorry, what is the full form of AI? It's giving full form of AI is artificial intelligence. It's working. Now the next question, even you can see in our document, there is informations regarding the natural language processing. Its NLP is also there. See, I can show you. We have see natural language processing. So I will ask the chatbot a question like, what is our question should be, what is natural language processing? We can ask that question. See, now what is natural language processing? I'm asking that question to chatbot. What is natural language processing? That's our question. See, chatbot is responding. Natural language processing. NLP allows machines to read and understand human language. See, there are some other questions. It's there. What are the traditional problems of AI research? That information also there in the document. You can see somewhere it's there. Traditional problems of AI research. It's there. So I am asking that question to the chatbot. What are the traditional problems of AI research? Problems. See, the traditional problems of AI research include reasoning, knowledge representation, planning, learning, natural language processing, perception, and the ability to move and manipulate objects. So you can see Wikipedia. From there only I copied all these informations. It's there in Wikipedia. These questions you can see. One more question I am asking here. That is, when artificial intelligence was found as an academic discipline, that is there in the document. It is, you can see, in the late, one second, if you see the document, see, I see the workshop. Okay, the field, the traditional. Okay, here you can see the traditional problems, traditional problems of AI research. The documents contains this information. The traditional problems of AI research, that is given here. You can that's what it's answered that. See, another thing you can see, artificial intelligence was found as an academic discipline in 1955. It's there in the document. We will ask this question. When artificial intelligence was found as an academic discipline. Let me ask that question. When artificial intelligence, what is the question, was found as an academic discipline. So it's giving artificial intelligence was found as an academic discipline in 1955, and in the years since has experienced several waves of optimism followed by disappointment of and the loss of. So that information also it's giving. So this is the way the chatbot works. So we have used TF-IDF vector and the cosine similarity algorithm. If you want more clarity on these two algorithms, you please watch my previous videos. So this is, I think, this is the 18th video on NLP. All the contents related to NLP is there in those 18 videos. You can watch those videos. So that's all. Thanks for watching. Please like, share, and subscribe. Thanks a lot.